Hi everyone, it's Miss Reese, and I am going over the Unit 3 test review. So we're starting out here with the tile pattern, and we are trying to determine how many tiles would be in figure 0 and how many would be in figure 4. So the first thing you want to determine is how many tiles are increasing from one figure to the next. I will be using the scratch pad a little bit. You don't need to use the scratch pad. You're welcome to use kind of scratch paper if you want to use that instead. So if we're looking here from figure 1 to figure 2, it looks like these 4 tiles on the ends are being added. So really it's an addition of 4 tiles. I'm going to put plus 4 here, and that is consistent for figure 3 as well. We're adding 4 tiles. And let's also write down the actual number of tiles we have for each figure. So that we've started with 5 in figure 1. We added 4 more, so we went to 9, we went to 13. So if we're being asked how many figure 0 has, we would have to backtrack and subtract 4. So if we subtracted 4 from 5, that would be 1 tile in figure 0. So figure 0 has 1 tile. Figure 4, we would need to add 4 more here, so plus 4, and that would be 17 tiles in figure 4. So figure 4 has 17. If we are writing our equation for this, remember in y equals mx plus b format, you can always have your toolkit out here. Let's look at our y equals mx plus b. M is our rate of change, and b, remember, is our figure 0. So if we are writing this, we have y equals, our rate of change was 4, and our figure 0 had 1 tile, so plus 1, 4x plus 1. And then if we want to figure out how many tiles are in the figure 200, we basically just need to plug in 200 for x. So we would say y equals 4 multiplied with 200 plus 1. So that would be 800 plus 1. That means that has 801 tiles. So when you're typing in your answers, I'll just kind of go out of the scratch pad now. So we had, okay, figure 0, that was 1. And then we had 17. We're writing our equation, so that's y equals 4x plus 1. Multiple variations of this will be accepted. If you had, some spaces in between that, that's also fine. And then we would just type in 801. You're welcome to check your answers if you want and see if you got them correct. And that's just the feature for the practice test. That feature will be turned off during the actual test though, okay? So we'll go to the second question. Now what you're doing is you are going to describe what figure 0 looks like. So we kind of talked about how many tiles was in that. And then what would figure 4 look like? So something you might want to talk about in figure 4, let me just add my scratch pad here, is you might want to say how many of these tiles you have here. So figure 3, it looks like I have 3 of these tiles coming from the center. And in figure 2, I have 2 of those tiles coming from the center piece on each of those 4 wings. So I would describe something about that for your figure number 4. All right, we have a new tile pattern here. First thing we want to determine is how many we have in figure 0 and how many we have in figure 4, just like we did in the last problem. So I would first start by counting 1, 2, 3, 4, 5, 6. So we have 6 tiles here. Whoops. Let me scratch pad. And let me make this just a little bit smaller. All right. So we have, 1, 2, 3, 4, 5, 6, 7. So we have 7 tiles here. And then it looks like we're really just, the only thing that's being changed is maybe 1 tile kind of in the middle here that's being added. Oops. So I would say that this has 8 tiles. And then this has this 1 more piece being added. So this has 9 tiles. So it looks like we're adding 1 tile each time, and it's kind of coming in the center or someplace in the middle of the eye is what it's kind of looking like. So how many would we have in figure 0? Well, if I'm adding 1 here, we would want to do the opposite and subtract 1. So we'd have 6 tiles. Whoops, that did not write out very well. Ignore that. We have 6 tiles in figure 0. And in figure 4, well, if I'm adding one more plus 1, we would have 10 tiles in the next figure. Just kind of one more in that center area. We have 10 tiles here. Your description about this should kind of include what we just talked about, what we're increasing by, what we start with, and your growth patterns. And then if we're writing an equation for this, so our growth rate, oops, we've got y equals, let me change over from my scratch pad here. Oops, we had 6 tiles in this one, and we had, what was it, 10? Yeah, 10 tiles in this question here. And so our equation was y equals 6x plus 1. I'm sorry, mixing those up. Y equals x plus 6. That's because our growth rate was 1. So it's okay to put 1x here as well. You don't have to. And then our first figure 0 had 6 tiles. Okay. And then for our last one, we're going to be plugging 200 into that equation. So essentially, I'm going to plug in 200 at x, and I would get 200 plus 6. So that would be 206. You can just type that in. And then when you go to the next question, you can always check these if you want. So go here. Oh, this one's not allowing you to check for some reason. But when you click next, it should say submitting response. Since it's a practice, you should be able to go back to it as well. Okay. Now we're looking for sorting these into arithmetic versus non-arithmetic. So if I look at the first tile pattern, I'm going from 11 to 14, 17 to 20. So if I'm not sure what I'm adding to get from one to the next, I just take a number and I subtract the number in front of it. So if I need to, I could take 14 essentially and subtract 11, and I'm getting 3. And then I could say, oh, okay, so 11 plus 3 is 14, 14 plus 3 is 17, plus another 3 is 20. Okay, so that pattern is consistent. That is arithmetic. I'm going to put that here. My next pattern goes from 2 to 4 to 8 to 16. I'm adding 2, then I'm adding 4, and then I'm adding 8. So I'm not adding a consistent amount. I am multiplying by a consistent amount, but that is not arithmetic. So I'm going to put that in this category here. We've got 5 going to 2. So if I take 2 and I subtract 5, 2 minus 5, I'm going to get negative 3. So I know that I'm essentially subtracting 3 each time. So I can kind of backtrack and say, okay, 5 minus 3 is 2. 2 minus 3 is negative 1. 1 minus 3 is negative 4. That is arithmetic. We've got negative 38. We've got negative 46. So I always take a number, negative 46. I subtract the number in front of it. Negative 46 minus negative 38. Whoops, this is a 38. It looks like we're subtracting 8 each time. So if we start at negative 38, we subtract 8, we get negative 46. We subtract 8 more. Negative 38 minus 8, we're at negative 46. We can subtract the negative 46 minus 8 to see if our pattern's consistent, and then we can subtract 8 more again and verify that it's consistent. So negative 54 minus 8 is, 54. Is giving us that last number, 62, yes. That is arithmetic, so, oops. I'm not sure if it matters where you're placing these. It shouldn't matter here. Here we've got, this is definitely not increasing by the same amount. I'm starting at 13, then 103. So it looks like we're adding like some digits there, so adding zeros in. So that is not arithmetic. I'm not adding a consistent amount if I'm going from tens to hundreds. Here it looks like negative 14 to negative 4. That's adding 10. And then negative 4 plus 10. Would that be at 6? It would be. And then 6 plus 10 is 16. So this would be arithmetic. Whoops. And sometimes you can zoom out and you can give yourself a little more space. So this is arithmetic. And then here we've got, this looks like it's dividing by 2, so we're not adding a consistent amount, so that is not arithmetic. And then our last one looks like we are multiplying by 3, so that is not arithmetic either. All right, on to the next question. Given the arithmetic sequence below, determine the common difference, and we're writing the rule for the 15th term. So we just want to know 7 plus or minus what number gives us the next number 13. So you can always just take that number 13 and subtract 7. So 13 minus 7, that's going to give us a common difference of 6. So D is 6. Our rule is A sub n, and if you don't remember, looking at our toolkit here, our formula, is remember A sub n equals dn plus A sub 0. So our common difference times n plus our 0th term, right? So our rule is A sub n, so can't really do sub on this. So I'm just going to do an equals dn, so 6n plus our 0th term. So we actually need to figure out what our 0th term is first. And where's my scratch pad? Here's my scratch pad. All right. So it looks like we're adding 6 to get to the next term. So remember, plus 6. So that means the opposite to get to the 0th term would be subtracting 6. So 7 minus 6 is 1. So I know that this would be plus 1 here. I'm going to add that in just a moment. And then we want to know what the 15th term is. So A sub n equals 6 multiplied with 15 plus 1. That's going to be our 15th term. You can actually write A sub 15 because that's the 15th term. So I'm going to put A sub 15 now equals, let's multiply 6 times 15. Which is 90, and then what are we just adding 1 to that? So this would be 91. The 15th term is 91. So when I go off my scratch pad here, I'm just going to put a 91. Oh, and I didn't need to put my plus 1 there. There we go. And in our next equation, we want a common difference. So from 53 to 46, we want to know what it is that we're adding or subtracting. So I'm going to take that 46 and subtract the number in front of it. So 46 minus 53. That's a negative 7. So a decrease of 7. I'm just going to type this in here for a moment. Oops. Yes, we're subtracting 7 each time. So if we're going from here to here and subtracting 7 in the opposite direction, we would want to add 7 to get our 0th term. So 53 plus 7 is going to be 60. So that would be the number that would come before 53 in the pattern. So we're going to write our rule as A sub n equals dn, so negative 7 times n plus 60 is what we're starting with. And then if we want the 20th term, A sub 20 is going to equal negative 7 multiplied to 20 plus 60. So negative 7 times 20, that's going to be negative 140 plus 60. And that's going to be negative 80. So going off the scratch pad here, then we will just type these in. We've got negative 7. A sub n equals negative 7n. What did I say? Plus 60. And then our 20th term was a negative 80. All right, now we're just writing our equation in slope-intercept form. So we need to know 2 things. We need to know our b value. That's right here. B is negative 1. And we need our slope. So I need another point to be able to identify it. So then I can count 1, 2, 3, 4, and to the right 3. So 4 over 3. My m is 4/3, and it's positive. I would recommend looking back in your toolkit if you're confused at all about the slopes and if they're positive or negative. So then when we type in our solution, it'd be y equals 4 over 3x plus, oops, I'll just do it lowercase s, plus or minus 1. Our y-intercept is -1. I write that here? Oh, good, I did. Okay. On our next question, and we're writing another equation. So our b value here is +5, and our slope this time is negative. And if I identify another point, here's another one. I'm just going down 2 to the right 1. So m is -2/1, which is just -2. So if we're writing the equation for this, it would be -2x plus 5. Y equals -2x plus 5. And now we're just going to practice actually graphing. So remember, the first thing we always graph is the y-intercept. So it's at +1. So I'm going to put a point at 1, and our slope is -2/5. So that means I can go down 2 to the right 5. Oh, let me get my line. Okay, it doesn't really matter what your points are called. I should have started with the line tool, actually. Looks fine. And then our next equation is y equals. So on my graph, I'm going to look on the y-axis and find a -6, which is here. And remember, a y equals graph is always horizontal. No matter what point you pick on that line, y is going to be -6. I recommend looking at your toolkit for that. So you can get a line, put a point anywhere that would create a horizontal. There we go. And we've got a line. We can have 2 points. If you want 3 points, that's great also. And then, oh, this one here, we're going to need to rewrite this in slope-intercept form. So I'm going to open up my scratch pad. Whoops, I closed out my scratch pad. There we go. So we want, where's my scratch pad? Okay, I was having scratch pad issues. We have figured that out. Okay, so we want to rewrite this in slope-intercept form. Let me close that. So that means we're going to subtract an x on both sides, subtract an x. All right, so that's going to give us a -2y equals -x. Sorry, that doesn't look like I subtracted. It should be subtracted on this side of the equal sign. Okay. And then we have a +0, so we don't really need to write that. So remember, our first step is always to subtract the x term on both sides of the equation. Then our next step is to divide by the coefficient of y. So we're going to divide here by -2. And here we're going to divide by a -2. So if there's another term after that, you would want to divide by -2 for that as well. But since we only have an x term and we don't have a b value, we're just going to divide by -2 there. So when I rewrite my equation, it's going to be y equals -x divided by -2. Negative divided by negative is positive, and it's going to be 1/2x. I'm having lots of scratch pad issues here. So I'm going to undo the scratch pad. And let's go ahead and graph it. Y equals 1/2x. And it's going to start at 0, up 1 to the right 2. And I should pick the line tool if I want to do a line. So I'll pick those 2 points and make a line through them. All right, now we're just writing our equation given slope and intercept. Y equals mx plus b. So y equals, the m is 7/3, so I just put 7/3x. And then our b value is the 5, so I just put +5, and that's it. And for our next equation, we've got y equals -2/5, that's our m, mx plus b. So plus a -10, oops, I usually don't write plus a negative, so I'm just going to put -10. That's the y-intercept. Now we've got some slope-intercept problems that are word problems. So we have some problems that are similar in your packet that we tried on Desmos. If we want to kind of go back to those, this page here were some of those practice problems. Let's go back here. So now we're just identifying the different variables. So we go to Cinemark Movie Pass. The flat fee is $12. That's like our y-intercept. So the one-time fee, that would be the 12. So I'm going to put my b value is 12, just since I'm reading it kind of in that order. And additional fee per ticket, that's like a rate of change, that's 15. And then in terms of x, well, if I multiply 15 times x, actually I want to write my equation first so this makes sense. So our equation is y equals mx, so 15x plus b, which is 12. So if I think about this equation, the x really represents how many tickets I have. So if I had 10 tickets, I would do 15 times 10, right? So this is the number of tickets. And for the y, well, if I've got 10 tickets and I multiply that by 15 and add 12 to it, y really represents how much I'm spending. So that's the total cost. Okay. So we've got our equation, we've kind of identified all our variables. And if we were to bring 4 friends, we are basically doing 15 times 4, so that's 60, and then 60 plus 12, that is $72. So we basically are just plugging in whatever number we had, so 4 tickets, 4 people, and multiplying that out. So if we want to show some work for that, I would go ahead and say y equals 15, you want to multiply that by 4, and then you're adding the $12 starting fee to that as well. All right, and our next problem, we've got 2 types of things. This is a standard equation, right? So with our standard equation, we have 2 quantities. So we're writing this in the form of ax plus by equals c. I'm just going to write that here. Ax plus by equals c. That is going to be the form of the equation when we finish. And sometimes it's kind of helpful to create your equation so you're identifying all your variables. So we have ax, so that's really how much something costs and the quantity of that, how many we have. by, that's another category, and then c is really the total that's being spent. So if I look here, oops, let me go out of the scratch pad. My equation, I'm going to say, is 7x, so 7 times one value, plus 5y, 5 times our other value, so cupcakes versus brownies, and then the total we're getting is 130. Okay, so now we're sure that we have our variables kind of identified here. So in terms of x, well, if I multiply 7 with something, that's going to be the number of brownies that I have. So I'm going to say x is the number of brownies. Oh, we started with cupcakes, sorry, number of cupcakes. Okay. And since it's 7 times x, 7 times the number of cupcakes, I want the y to be the cost of the cupcakes, or the a to be the cost of the cupcakes, sorry, cost of cupcakes, which is the $7. And then for y, that's our other variable, that is brownies, so number of brownies. And then b is going to be, so 5 multiplied times the number of brownies, that's the cost of each brownie, cost of brownies. And then c, that's our total sales. Okay. Now we're going to solve in this equation if we sold 10 cupcakes. So let me just do a little scratch pad here for that. If we're selling 10 cupcakes, let me make sure I'm on the writing tool. Selling 10 cupcakes, that would be $7 per cupcake. So we want to know how many brownies. So basically we would do 7 times 10 plus 5y, and we're equaling that to 130, which was the total sales. So this is going to be 70 plus 5y equals 130. And then I just need to subtract a 70 on both sides. So I'm going to be left with 5y equals, is that 60? And then we're going to divide by 5. Let's do 130 minus 70. And then we're dividing that by, oops, I'll just restart it. 60 divided by 5. And that's going to be 12. So y is 12 here. All right, so when I move my scratch pad, I can just type in the answer. It's 12. We'll go on to the next question. We are given the point and slope, right? The equation in slope-intercept form. All right, so we're putting this into the format. We've got y minus y1. So this is our x1 and our y1. And this is our m. So remember in this format, it's y minus y1 equals m times x minus x1. So we get here y minus y1, which is 0, y minus 0 equals 3 over 2. And then we've got x minus a negative 2. And remember, whenever we're subtracting a negative, I'm going to really change that to become a positive. If you want, you can write that as a separate step. Not really necessary. And then the next thing we would need to do is go ahead and distribute 3 halves into x and into 2. And then if I have y minus 0, I'm just going to rewrite that as y equals. So 3 over 2 times x is 3 over 2x. And 3 over 2 times 2, well, the 2's are going to simplify. It's really 6 over 2. So that's just going to be 3. That would be your answer for question A. And on question B, I'm going to label this as x sub 1, y sub 1. And this is going to be your m. So I'm going to type this into our equation, y minus y1, which is y minus 5, equals 2x minus x1, which is our 3. Our next step, we could go ahead and distribute. That's going to give us y minus 5 equals 2x minus 6, and then we're going to add a 5 to both sides. That's going to give us y equals 2x minus 1. And then I'm going to have you try question C on your own. This is x sub 1, y sub 1. And then we have our m, and we're plugging that into the equation. And then our last question, a little variation of this. We're going to do the first two together. We are given 2 points. We're going to write it in slope-intercept form. The first thing we need to do is find the slope. So let's remind ourselves of that formula. Make this a little bit bigger. So remember our slope formula. There we go. Our slope formula is m equals y sub 2 minus y sub 1. Change in the y over change in x. X sub 2 minus x sub 1. So below each of these points, I'm going to label them x sub 1, y sub 1, x sub 2, y sub 2. So your first step here is just to find the slope. That's going to be 0, y2 minus y1, 3. 0 minus 3. That is going to be divided by negative 4 minus negative 1. This will simplify to a negative 3. And 4 minus negative 1 is really 4 plus 1. Negative 4 plus 1, that'll be a negative 3 as well. And this simplifies to 1. Now you have your slope. This is our m. M is 1. We're going to use this point here. You could actually use either point, it doesn't matter. So we're going to put this into the equation that we just did on the previous slide. Y minus y1 equals m times x minus x1. This is an m. There we go. So we've got y minus 3 equals our slope, which is 1, and then x minus a negative 1. Well, I'm going to change this to plus so I don't have to rewrite that whole step. Now we can distribute. That's y minus 3 equals 1 times x. That's just a 1x or x. And then 1 times 1 is positive 1. I would then go ahead and add 3 to both sides. Get this in y equals format. So our final equation, y equals x plus 4. And then you have a few others that you're trying here. I'm going to let you try question B and question C on your own, and I'll try the last one with you. We've got x1 Oh, I don't know why that's not letting me write on there. Maybe it wants me to have something on each of these little parts here. I don't know what's going on. Okay, so we've got an x sub 1, y sub 1. We've got 5, negative 3. Ignore this. And then we've got 0, 3. The scratch pad's acting up here. So this is our x1, y1, our x1, y1, and our x sub 2, y sub 2. Okay, so first thing, finding the slope. That would be 3 minus negative 3. And then y2 minus y1. And then 0 minus 5. So this is going to simplify to 6 over negative 5. And that is going to be negative 6 over 5. So I'm still on this question, but for some reason the scratch pad is not working down below. So I'm going to say y minus y1. So that's going to be y minus a negative 3 equals our slope, negative 6/5 multiplied with x minus 5. So that's now in point slope form. I'm going to change this to a plus here. I'm going to go ahead and distribute. That's going to give me y plus 3 equals negative 6 over 5 times x. That's just negative 6 over 5x. And then negative times the negative here, I'm going to get a positive. The 5s will simplify out and I'll be left with 6. And my last step is just to subtract 3 on both sides. So my final equation is y equals negative 6 over 5x plus 3. That would be for question D. You were trying B and C on your own. Please let any of your teachers know if you need help on any of the additional problems. Good luck on the test.